Hello viewers, thank you for joining us. As you can see in my screen, this is my website and the name of the page is Rainfall Analysis and Prediction in Australia. So what I have done is that a few months ago, or maybe 1 or 2 months ago maybe, I have done a machine learning project by taking 10 years rainfall data of Australia, and I have done exploratory data analysis. You can find it here. If you click this icon, you will go to my Jovian profile where I have uploaded this notebook, and this is the exploratory data analysis, which is not the goal of today's video. I have done this. You can surely look at my work, and after that, this is the machine learning model for prediction. You can also click this button to go to my Kaggle notebook where I have stored my work, and this is my Kaggle profile. You can find the notebook here. The complete machine learning project can be found here, and I have tried to make prediction using several algorithms, and I tried to implement several ideas related to rainfall in Australian region. So one of the professors actually take a look at this project of mine, and he commented that why I'm not creating, or he commented that he thought I would create a map for this project. So I considered this opinion as a very concrete opinion and concrete suggestions. So I created actually these maps, and this map was done by ArcGIS desktop, and after that I also used I also created this map, this interactive HTML map by Folium. But the problem was that I did not have any geometric data available for creating these maps. So the purpose of today's video is that I'm going to show you, if you do not have geometric data available in your case, then how can you use GeoPandas, a Python package, to create your own geometry for the region and use those latitude and longitude values to create your maps efficiently. So this is as I have created this, I thought, why not make a video so that I may help somebody. That's the purpose of this particular. I'll be I will not take much time because I have already done the job. You can see my code in this Jupyter notebook. I think you are all familiar with Jupyter notebook, what it is, how to install it. So those are not the scope of my video today, tutorial today. What I'm going to do is just I'm going to show you how to create that folium map and how to generate those geocodes so that I can use those geometric values to create Excel files or to create maps in ArcGIS. Okay, so let's dive into the project. You can see my Jupyter notebook. First of all, let me clear the output so that we can see them fresh. We start and clear output so that all the output data actually goes away. Okay, so yeah, you can see all the outputs have gone away, and I only have these few codes. So this is not a big deal. You can see that to actually write these codes, if you know the process, it's not a big deal. But still, I had to take some time to actually fix some issues which I had during the project. So it actually took a bit more than maybe an expert user or who is quite familiar with folium, geopandas may take a little shorter than what I took. Okay, so just start. First of all, what I did is I just imported the necessary libraries. So let me make a comment: importing necessary libraries. Okay, so you can see I have imported pandas, geopandas. Actually, I did not use matplotlib, so this is an extra. Yes, I don't need that. And I have also imported geocode, nominating, and folium. Shapely, from Shapely, I have important points specifically for purpose, which I'll be talking later. So first of all, the data I used for the machine learning model is the Australian weather data, which can be found in Kaggle. You can see these weather Australian c.cs weatheraus.csv file. That is the file I'm working with. It's also saved in my local machine. This is the CSV file you can see here. So this is the CSV file. You can see that there is no latitude or longitude values here. If you look at the column names, these two lines, you won't see any latitude or longitude data in this particular CSV file. So how I generated these coordinates is the purpose of the video, as I've already told you. So let me import the data first. Import data. So I have imported the data by using pd.read.csv. PD is a very popular pandas command. Let me first import the libraries. I haven't imported it yet, so and name error showed up. So when these libraries are imported, then this error message will not show. Okay, it's taking a bit time. Okay, my necessary libraries are imported. You can see the shell number here is 1 and here is 2. This is because I ran this particular shell. So this is the kind of chronology of execution. And in the number 2 cell, in the number 2 of my running, I ran this particular cell. And now if you run this cell, you can see this will be 3, and I have imported the data successfully. So I can take a look at the data and look at the CSV file, which is now will be converted to the tabular pandas data frame format. This is a pandas data frame, and you can see the column names, date, location, mean, max, temperature, rainfall, elevation, which actually I used while predicting the next day rainfall, rain today, rain tomorrow. This rain tomorrow was the target column when I was creating the machine learning model, and I had used most of the columns for training purpose. But that's another topic. I'm not creating this tutorial or video for modeling purpose. I'm just creating these to show how to create a map if you do not have the location of the coordinates of the locations in Australia or in any region in the world. So when you have imported the data, actually while creating the location, I only need what I have done, you can see in this map. Actually, I created a map for mean rainfall between 2008 and 2017. So you can guess that I only need the location data, these points, these points, and I need the mean rainfall. That's the two columns I need for my purpose, nothing else. And I'll be talking about the left map later. You might be thinking, why are you not talking about this left map? I'll be telling later that why I have created this map. Basically, my project is based on this map and this map. But why this map? I'll say later. Because I actually had the data for this left map. I found this online. That's the reason I found it online. Let me finish it here. I found the data for recent rainfall from October 2020 to November 2021. That's in this month. So I found this data online, and I just created a map just to visualize how rainfall patterns is actually is happening in Australia. So I just got a quick view of Australian rainfall. Then I was trying to create a rainfall map for my own data, and I was missing those location data, so I created those. Okay. So to have the unique location, you can use this pandas command, raw data of location dot unique. This will give you a unique location values in a list. Like if you now run this command, you are watching that Albury, Badgerry Creek, Coburg, Coast Harbour, Moree. These are the particular locations in Australia where those rainfall stations were placed or are placed. This is the particular column. You can see that there are lots of data for Albury, because Albury data is available for 2008, 2009, and others, but I'm only taking the unique name of those locations so that I can use that for further future purpose. Now, in the next shell, what I have done is that I have created a new data frame, and that is with the location column and the rainfall column. Because from this new data frame, I'm going to create mean rainfall and location dictionary and rest of the process. You can check some more attributes, like this was only for my, actually for some exploratory data analysis kind of thing, but this is not actually necessary for this code, so I'm deleting it. Okay, now what you can create is to start with the rainfall empty dictionary. In this dictionary, what I'm going to do is for each unique location, I'm going to create the mean rainfall by using a for loop. So for each particular location in this list, so I have used this command for location in location. For lock in location stands for location in location. In this empty dictionary, I'm going to use the key as location and the value as the mean rainfall. So for mean rainfall, you are going to use this command, new df.rainfall will give you the rainfall column, and for those columns, the individual location will be passed to extract the data of those individual locations, and dot mean stands for the mean rainfall. So I need to run this line and then this line. So my dictionary is created. You can see the dictionary here: rainfall dict, Albury, Badgerry Creek, and all the places. So when I am done with the dictionary creation, now I'm going to convert this dictionary to Pandas data frame. As we will be using the data frame for the rest of the notebooks. And data frame will help me more than the dictionary. So mean rainfall, pd.data frame list, rainfall leak.items, column names or location, and mean rainfall. This is just a command. You can take a look at that, look at these, and if you're familiar with pandas and Python list, this kind of stuff, so you'll be surely able to understand what I'm talking about. The purpose is not to teach you pandas or Python. I know all of you who are actually watching this tutorial should know Python and pandas, but I'm just showing you how to create the map or what kind of codes you can use. So when you are done with mean rainfall data frame, you have created a data frame out of the dictionary. So now we can see the mean rainfall DF, means data frame. Here you can see there is an index column, a location column, and mean rainfall column. All I need is these two columns and the locations XY coordinate, which are missing in my data because I didn't have any particular XY coordinate in the main CSV file, in this file. So I have to create those. But firstly, I have made a cleaning process. Like I do not need evaporation data, sunshine data, wind gust direction data for my purpose. So I have just left them, just cut them, and I'm only with location and mean rainfall data now. So here comes the interesting part and the most important part of this tutorial, and that is to create the geocode, or that is to generate geocode location data from your location names. So here are the location names. These will be my input data kind of. So first of all, you have to create a geolocator, and that is using a nominating. There are others as far as I know in GeoPandas, but I'll be using nominating, and you have to provide your user agent if you're working in local machine. What's your name in your computer? Like my name is my own computer is Sheikh Asif. You can also use your own name, and if you're working in a public or company computer, maybe then you have to use something else, but you can definitely research and find out those. That's up to you. I think that would not be a big deal. Okay, then you have to actually iterate through this data frame by running a for loop, like I have done here for index comma row in mean rainfall df.iter rows. These iter rows will give you the option to use each index and row in your data frame to iterate through your each element, and kind of these will be used to locate other things. If you this will help you to place other new data into your columns, and in particular columns and rows. So here I have used the try and except block so that I do not get any error message, like while if you are working with lots of data, like here I have only 48 location names, or maybe 49 because we have started from 0. So we have only 49 rows. So this is not a big deal. But if you're working with hundreds of data, and there are the names of the location are written in Arabic, Chinese, Japanese, so these could be written in several languages, because we know that locations are from different regions. So some error may occur, and to actually handle that error, we have used an exception block. Though in my case, actually it was no problem was created, but in your case, when you're working with your own data, some error may occur, so you can use this exception block. And in this first block, the try block, I have used the necessary code to generate my location X and location Y. Here you can see that first of all, I have printed the name of the row location just to keep a track of how my code is running. I'll soon run the code to show you what's happening here. And then I have created an info variable, and in this info variable I have created the geocode by using these the row from every the name of the location from every row. So I have used the row of location that will create the geocode, and I have to convert it to string because there might be some numbers or some other data types which need to be converted to string. And when my info is created, I am using this info. This info has several parameters like the geometry column. When if you just, okay, let me show that to you. If you just break the for loop in this moment, you can see the info column. Sorry, the info data frame. It's kind of a data frame. Here you can see that the info data frame has geometry column and address column. This address is for Albury, and for each of the locations in my mean rainfall data frame, an address will be created, a geometry will be created. For most of the region, for some regions, the geometry might not be available, or the process might not create the geometry data. They might create NaN values, and we have to deal with those later. I'm going to show you those things. But for particular this Albury region, we have found the geometry, and that is point, longitude, and latitude. So when you are done with that, you can see that there is also address, which we will not need for this particular project, but for some other tasks you may need the address as well. So let me delete this break thing because I have to run the for loop for each of the element. And if sometimes if your location is empty, I mean you are not getting any values from the geocoding, so some error may occur. So in those cases, we'll replace those empty thing with 0 points, and that will fix the issue. So I have written an if conditional statement. If location that is empty is equals to true, then location is equal to point. In the tuple, you'll pass 0, 0. So that's the code. And else, if you have the data, I mean, you have the address, X coordinate, Y coordinate available for your data, this will go in the else statement, because if there is no data, you replace it with a 0 point. But if you have the data, then you'll just create 3 more columns beside mean rainfall. There will be address column, there will be longitude column, there will be latitude column. So I have just done this in these 3 lines of codes. So look for address column, I have used this particular line, info of address.log of 0. The log function, you can search it online how it does its function. What actually it does is it uses the labels to locate your data to a data frame. And I have used this function to create my address column. Location.x means longitude column, and location.y means latitude column. Here you'll find the lon and lat, which are denoting the names of these 2 columns. Soon we're going to see how my data frame is going to look. See, these names of the locations are printing because I have used a print row location. It's just for, you know, having a track of my work for my own purpose. It's not important to print anything, but as it will run for long, you may thinking, have I created an infinite loop or um, other weird things might come in your head. And to remove those confusions, I have just used this print row location, which you nicely print the region so that you may track that my work or my code is at this stage of the game. So now when you have run this particular snippet of code snippet, so now I'm just going to see what my mean rainfall DF is now look like. So you can just see that the location and mean rainfall were there prior to running that code, but now I have extra 3 columns, and that is address, longitude, and latitude. So, but you see that there are several columns which did not have any values, so we replaced it with nan values. 0.00 the 0.00 command that he used has created some nan here. Okay, so we have to actually delete or remove these nan values for our purpose. So we may lose some citations, but all we need to have a general understanding of how rainfall in Australia looks like. So that's not a big deal if you delete 3-4 columns from our data. You can see here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, not very small, but what I can do, I didn't find any better option for those, but still 30 or 35 columns or 35 rows are quite good to have an understanding out of 50 maybe. Okay, so I'm just removing the nan rows by mean rainfall DF or drop any command, and if I want to use this file in ArcMap, then I have to create an Excel file, which I'm going to show you that how I have created a rainfall map in ArcGIS. But this command is to create a mean rainfall australia.xlsx. Actually, I have already created this, so maybe I can comment out this line. You can run that if you want to create an Excel file, but if you do not need the Excel file, you can just leave it for now. Okay, I'm done with mean rainfall DF. Okay. I have dropped the rows and created an Excel file, which I have already created before doing this video. So I have in this my local machine, and now I am going to create a new data set that will read the Excel file that is stored in my local computer. And after you read this data set, you can see that the new data set has an unwanted column, and that is named unnamed 0. These unnecessary column is created, so we can delete this using del new data set unnamed 0. If you run this command, that particular column will be deleted. And now if you just run this cell, you see that this named column is gone. So pretty good. It's nice to see a clean data set with no nan values. It's quite interesting. So you can see now we have 36 instead of 48 in the last value. We have 36. That means we have 37 columns now. Prior to run the commands that we have just run, we had 49 rows. So Good. Okay, now we'll create a map variable using folium. Folium is a package that is used to create interactive maps. So here we have used the OpenStreetMap tiles, and this is easily available and freely available, but for some other tiles you need to have to do some API kind of thing, which is actually not suitable for my case. So I haven't used those. I have just used the OpenStreetMap if I want to create an interactive map that I have created here. So let me run the command and show you the map in the Jupyter notebook. Okay, when you're done with the map variable, you may like to add some marker in the some marker like these in your map. These kinds of markers where if you click, you'll see the location and your mean rainfall. That's the two important parameters we like to see in our map. So if you want to create this thing, you may run this for loop in the new dataset.iteros, just like before, just we did in the case of our geocoding for index row in mean rainfall df.iteros. We did that. And now we are just doing for index row in new dataset.iteros. The for loop is kind of same, but the body is different. And here we are use the folium.marker operation, and to create these markers, we'll create these things and add to the map. Add to m means this m variable. So when we are done with these operations, these marker operations, we will add these to the map. So you can explore, and for your case it may be different. You may not use, may not have the name of the location as location. You may have instead the name of the column would be name in code, and you may do not have mean rainfall. Instead your case it may be area, so you may need to change these things and customize for your case. Okay, have I run this? Yes. Okay, now let's run this command. Now I have done with the map. You can just run m variable to see your interactive HTML map. Here it is. Okay, quite nice. But what are these? Are these Australian region? I see that this is Italia. Okay, wow. And this is California, maybe. What is that? Portland. It's in Canada, Walpole. Wow, Albany. So what is wrong with that? Actually, what happened is that, you know, there are locations in the world that bear the same name. Like there may be Albany in both Australia and United States. So maybe our geocode operations have taken the name of the Albany in that lies in United States instead of Australia. So we have some location that's out of the Australian region. It may happen also in your case, and that's common. But still, you'll get most of the relevant data in the relevant region, and that is Australia. Like we have Uluru here, Perth, Witchcliff, pretty weird names. Nora Head, at least for myself, because I'm from Bangladesh. Brisbane, Sydney, Hobart. Actually, Hobart, Melbourne are quite familiar to me because we are a test playing nation, and we have to play test with countries like Australia and other countries. So sometimes the test matches, cricket test matches are held in Hobart, Melbourne, Perth, and these kinds of places. So that's the map. And if you want to save this HTML map and embed in your own website, then you can use this command. I have already saved it, so I'll not run that command. m.save Australian info stations, and that will create a map. Let me show you the map. if you want to view in HTML file. Okay, where's the map? Australian rainfall stations of HTML. So if you come to the page, you can also run this from your own computer and watch the map. And what can you do is you can, if you open it on Google Chrome, you can watch the page source. This is the page source, and you can copy these codes and embed to your website. What I have done here is I have copied that code snippet and embed the code to my website project page. And that's all. That's all as far as generating geocode and creating folium map using GeoPandas is concerned, using Python is concerned. So, but here are other two maps which I have created in ArcMap in ArcGIS, but that's not the scope of this tutorial. There are lots of tutorials available in YouTube and other platforms that talks about how to create maps in ArcGIS. So you can take a look at that, or maybe I may sometime also create a separate video for this creation of these kinds of maps. But just if I open just to show you how I created the maps in ArcMap, I can show you that. Actually, ArcGIS sometimes takes a bit longer in my local machine. So yeah, it's coming. Okay, nice. So let me enlarge this. Okay, here you can see my maps, and that's for mean rainfall between 2008 2018. So first of all, what I have done is just let me tell you the overall process how I created this map. First of all, I just converted my Excel, import my Excel file to this ArcMap, and then convert it to table data, and then after that I have just export the data and create a shapefile of this historical rainfall. If you just unclick, then you see all the regions are gone, but if you click in this historical rainfall data, you'll see these regions. So after that, I have used IDW method to actually interpolate rainfall patterns, and by using that IDW method, I have created this map. I have also used another AUS ADM, and that is to actually denote the boundary line of Australia. Just see, if I unclick this button, this boundary line is gone. So Australian administrative data, I have used that to create an outline. So that and it was also used for in IDW operation. It was used also. So this is the one, and I also had the other thing. Okay. So actually, I was talking about this map. Maybe that's a separate file, but that's actually it's not our concern for now. So I've just shown you how I created this map in ArcMap. This is pretty straightforward, not a big deal. There is no coding. All you just need to do, drag or insert legend, north arrow, scale bar. This is legend. This is north arrow. This is scale bar, scale text, and title. All will be found here. You just click those and fix your map with these values or these parameters or whatever you want to like them to say. So that's now, I think, creating the ArcMaps quite straightforward. There is no coding. So I hope you will be successfully able to create the whole project by yourself. So now we are done with the code and done with the arc map. Now we have a complete kind of, maybe if somebody gives a good suggestion in the comment box, I may try out those as well. So that's all for now in this particular project, rainfall analysis and prediction in Australia using machine learning and visualization of the rainfall data in ArcMap and GeoPandas, Python, and folium. So hope you have enjoyed maybe the tutorial, and if you actually got some benefits from the tutorial, that's my pleasure. Hope to see you soon. That would be great if I can come up with another tutorial. Up until then, thanks. That's all.